Great. Thank you, Gabby. Good morning, everybody. Hope you're doing well today. We have an exciting webinar today. We're joined by Greg Hogan, who is a science instructor. My name is Jason Oliver. I am the architecture professor at College of the Canyons and also a senior personnel for the Create Energy Group. Just a couple of announcements before we pass the baton over to Greg. If you're interested in learning more about Create, you can visit our website at createenergy.org. And on there, you can find out about some of the upcoming events that we have coming up, both in person as well as some of our virtual ones, including a coffee hour that's coming up in May, mid-May, which was a rescheduled one for learning about recruitment in the energy fields. And then also we have, as part of our innovation series on May 8th, a webinar on decarbonizing domestic hot water generation. So that'll be a lab webinar. If you have any questions, feel free to email Gabrielle Temple at the email that's identified on the screen here. And so with that, I want to introduce Greg Hogan. Greg is a middle school teacher with 24 years of teaching experience. He's out of Buena Vista, Colorado, or you may pronounce it a little bit differently, which is a small rural school nestled between the Rocky Mountains and the Arkansas River. And when he's not teaching, he likes to go mountain biking and skiing with his wife or unwinding with a good book. Greg has two daughters, one with a nursing career and another currently in college. And the way that today's webinar is going to work is that Greg has two lessons, science lessons that he'd like to overview, and that we're going to do a Q&A after each lesson. So if you have any questions, feel free to type them into the chat and we'll try to address those at that break between the two lessons. So with that, Greg, please feel free to take over and welcome.
Well, thank you so much for that introduction, and thank you also to the Create Energy Group. Just a little background for me with I did get to go to a workshop with them a few years ago. That was in Denver, Colorado, and it was fantastic. Some of what I'm going to be sharing in this webinar comes from some adapted materials out of that workshop. And I would highly recommend if one is coming near you or you see a topic that is of interest to you, to take advantage of that because they are fantastic. Also want to say that it is a little awkward for me to do a webinar. I'm so used to interacting with students, and so pardon me if I seem a little off, but hopefully we can get some good questions and a little bit of good discussion going in the midst of my presentation. As we mentioned, I'm going to do two lessons, and both of them are pretty simple. I've been doing the first one I've been doing for years, and I'll jump into that. Years ago, it was about probably 22 years ago, we were really starting to focus on transitioning from fossil fuels for our energy resources to alternative methods. And I really wanted the students to learn about those, but I didn't want to go through the traditional direct instruction. So I did the jigsaw method, which probably many of you are familiar with. And basically that just means splitting the kids into groups, making them experts over a certain topic, and then having them present and share with everyone else. I'm going to share my screen, and we were practicing this yesterday. Hopefully it works great. We'll see how it goes here. Give me just a minute. Okay. All right, tells me I'm screen sharing. So if you can't see my screen, means let me know. Hopefully this is working out great. I'll start out and just show you some of the paperwork that I give to the students. This is the introduction for the energy presentations. And I try to make it fun and just tell them, hey, let's pretend that it's 35 years in the future. The population of our town is now 30,000, which would be a significant enough resources to access fossils, split into 7 or 8 groups. Each group has a source of power. So there's solar power, nuclear power, hydroelectric, geothermal, etc. You can see that on the second paragraph here. Once they get their source of power, they're asked to split themselves into different jobs. So one team is a scientist. Their job is to explain how their source of power works. The second person team is the advertising agent. Their job is to explain the advantages of their source of power. The third is a consultant. Their job is to address the disadvantages. So they have to acknowledge that, hey, here are some things that are not good about our particular source of power, and this is how we're going to deal with that. So for example, solar power, the sun's not always shining, even here in Colorado. So one thing you could do is you could have batteries to store the power overnight or when the sun is not shining. So the consultant's job is to address the problems of the source of power. The last person's job is engineer, and their job is to address the logistics of their source of power. In other words, where is the power plant going to be located? How is it going to be built? What sort of maintenance needs to happen, etc. My group sizes are usually 3 to 4. If they only have 3 in their group, I will tell them to not worry about the engineer job. But if someone in the group wants to do the job, they can do it for extra credit. Generally, the groups jump on that, and I will get them. Most groups will do all 4 jobs, and they'll either share the extra credit for the 4th job, or one of the students just really gets into it and wants to do the extra work, and that's fine. So what they do is I was trying to think about how much time they spend doing this. I think I split it up into 4 or 5 class periods where they gather the information and they set up their presentation in a Google Slides format. But I don't give them the whole period because I teach middle school and their attention span is anywhere from 15 to 20 minutes for an activity. So they will get probably a total of about 100 minutes split over 5 class periods, if that makes sense, to prepare for this. So they do set Google Slides, and I tell them, you're just responsible for 1 slide. Your job is to describe the 5 things that you're responsible for in your slide, include a picture, and tell us about it. So on this picture, they share the Google Slides with me, and then we can throw them on the screen up in front of the room, and then they do their presentations. I have a page for each job. So here's the scientist job, and you can see I have a couple extra questions in there, and then they need to describe the 5 steps for how their power works. I am to sources, so I have a space for bibliography, so that they are not just pulling their information out of thin air. And then for evaluating their presentation. So initially when I had this, and I did it for years, I did it as a debate. And you can do the debate. I've included the scoring criteria at the end of this paperwork that you can take a look at. But I like it better as a presentation because I guess it's I don't know. I think it's more democratic. I'll put it that way. So there you go. So when I evaluate the presentation, I look at quality. Are they actually engaging the class and not just reading from the screen? Information accurate, which sometimes not so much. They actually complete the task. So pretty simple. Here is just 20 points in my classroom, which it is what it is. But so that's the agent's same idea. They are doing the 5 advantages presentation. Same idea. They're doing 5 disadvantages and how to solve those with the presentation stage. And they do their, they kind of take care of 5 different details. If you want, here's a way that you could do a debate where you would score the different teams and then average out their scores, and they do wins. Like I said, I really prefer it to be a presentation. Like I said, I think that's a little bit more dramatic. So I introduced this whole project by showing them my own presentation so that they can see what the presentation looks like. And in my presentation, I just do a presentation on fossil fuels, which is obviously on its way out. That's the whole idea behind this. What are we going to do next? But it's great because the kids like to pick it apart. With my advantages, I like to say how cheap they are. And they like to say, well, do you have to pay much for solar power after the solar panels? Or when I'm addressing the solutions, one of my problems of fossil fuels is pollution. And I tell them that we're going to help solve that by planting more trees, which does help, but it's not really solving the problem. So like I said, they have some fun picking apart my presentation, but at least it enables them to see, hey, this is what it looks like. And then they can use that. I think that that's very, very helpful. What else? Oh, so do the presentations. They generally have a lot of fun with. This is a 6th grade project. I think it's doable. I think it's doable on other levels by all means. After they do the presentations, then I have students reflect, and in their reflection, I'll show you the reflection next. So form. And the reflection looks like this. Try to scroll through slowly enough. Basically, I asked them, what do you think is best? What do you think would be best for our alternative for our energy needs in the future? And I do talk to them. I say, you don't have to pick one thing. You can pick a combination of just why that's the best option. That's the best option. Describe a solution for a weakness, and then of course describe a second solution for a weakness. The idea here is for them to have eyes for the future, to see how energy needs are changing, why they're changing, and that there are pros and cons to all of the different ideas and solutions that are out there. And they, like I've mentioned, they do get really into it. In fact, I teach both 6th and 8th grade, and I've had 8th grade students remember, which is like, hey, that's a win, from 2 years ago, and even say, hey, did you see that new research in nuclear power, and getting really excited about things years after the activity, which to me is a good sign that they have actually internalized some of the information and are really thinking through it. It's also been neat to see our local electricity company started out 20 years ago using, 7% alternative renewable energies, and now they're up to 40%. So things are really changing, and the kids get to live in that world and understand why it's happening and what it would look like. So anyway, that's the first lesson, and I'm ready for questions.
So we've got a couple of questions in the chat, and you kind of touched on the first one, Greg, but what are the primary sources of power in your community, ones that the students would see, and how is that used as a positive or negative source in relation to the learning outcomes for this lab? And then secondly, does the class get a chance to visit any of these power sources?
Those are great. Y'all are teachers. That's awesome. So first question, primary sources of power. Most of our current energy needs come from coal. And we do actually have the local electricity company come in. They talk them through electrical safety, and we do have good discussions about the power plant that supplies most of our power. Interestingly enough, Buena Vista is very windy sometimes. And if you were to ask the average Buena Vista citizen um, if we lived in a windy climate, they would tell you that it is so windy here. But the irony is that it's only very windy occasionally, and wind power is actually not a good source of alternative energy for our local climate. What we do have a lot of is sunshine, and sunshine is an excellent source of power. And so we do talk about the solar panels that are around town, and both the new ones and the ones that they've seen for a while. We also have some hydroelectric energy. We don't have any on the river that the Arkansas River that a few you and I talked about earlier, which is good because we have a lot of rafting and recreation on that river. But on the mountain lakes, we do have a significant energy source, hydroelectric power. You asked if students get to visit those. That's kind of funny. Students visit the fossil fuel plant, that would be hundreds of miles away. So they're not visiting that. Many of the students do fish in the local reservoir that does produce hydroelectric power. And it's often news to them that that generates electricity. So that's fun. And they do see the solar power around town, but that's generally not a centralized location. It's more an independent venture for residents that live in town. So it makes for some good discussions because, like I said, living here, a lot of people say wind is a great option, but it's not. And I'm actually going to address that a little bit in the second lesson that I show.
Okay, great. And then a couple other questions. One is, how do you handle it if students present incorrect information in their submittals and their projects? And then also the second part of that is, although the time frame for the lesson asks for the students to project and imagine they're in the year 2050, are they using current, energy statistics and information for their presentations?
Ooh, great questions. Um, so, how do I handle incorrect information? So I wait till the presentation is over. I compliment their efforts, and then I will just directly address any incorrect information. And in fact, with presentations, it's tricky as a teacher. You have to let go of control, and you have to say, I'm going to give the students control during this time. Um, and that's a good healthy thing because ownership is really important for them to have over their own education. But if they do make some mistakes in information, then I definitely address those right after their presentation before the next presentation begins. And that also brings up a second point, something that I think I included in the paperwork, but I forgot to mention, and I could pull it up if anyone would like to see it. But when the students who are not presenting, when they're listening, they are also taking notes on a chart where they're writing down how the energy is produced, what the advantages of the energy are, and what the disadvantages of the source of energy are. So they're all, not only are they listening, they're also taking notes on a paper that they eventually turn in for me to evaluate. It's kind of two places for me to take care of misinformation. One is right after the presentation, and then the second one is when I get the paperwork back from the students, their observations on the presentations, I can correct information on that. So yeah, great question. And like I said, if anyone wants to see that, I pull that on my computer and show you. It's just a simple chart. As soon as you take this with. range 20 question. I do not have them extrapolate. I just have them use current information. Um, Extrapolation, that sounds like that would be a really great idea to use for maybe an 8th grade class or high school class. I like that. That's great.
Well, thank you, Greg. So why don't we move into the second item, and then that'll possibly prompt this, other question or comment, which was related to hydroelectric plants. That sounds like there may be some in Colorado that could be interesting for students to visit if given the opportunity.
Right. So after doing this presentation, or these presentations, after doing this project, then I have students, like I said, reflect on it. The next day after their reflections, then what I do is I have students experiment a little bit with solar energy and experiment a little bit with wind energy. And this is definitely an evolving lesson, but I felt it was worthy to share because it's so adaptable and so usable. And I'm going to pull it up here on my screen. One of the challenges that I ran into after going to the Create Energy Group workshop was they had some really fantastic ideas that were not to use with a group of students. And one of the things that that they did is they gave us supplies to test out wind turbine designs, which is awesome. But for 25 kids, it's really difficult to have a group of them working with the wind turbine and then all the rest of them watching. It's easy to do with adults because adults have a lot of patience, but in my experience, that's not always true with middle school students. So what I did is I came up with basically something for most of the groups to do while one of the groups was testing out a wind turbine design. So the basic gist of this lesson, it's a Google form. And if you are not using Google Forms in your classroom, but you're looking for some way to organize and facilitate instruction, Google Forms are awesome because you can adapt them. You can put all kinds of activities on them and website links and videos. They are just so fantastically usable for instruction. So basically, I will give cardboard to all of my groups. Like I said, 7 or 8 groups. They all get a big thing of cardboard. And I explained to them that they're going to be cutting out turbine blades for a wind turbine. And we're going to test how well their designs work. So while they're cutting them out, I say, when you're done, go ahead and go through and work through this Google form, which is hopefully you can see on your screen. And I'm going to scroll through it here in a hot minute so you can see what's on the Google form. So what this does is that as soon as one of the groups is done, I call them back. We try out their wind turbine blades. And meanwhile, everyone else has something to do because they're working on the alternative energy exploration Google form. And then when I'm done with that first group, I call the second group back. And so they all have something to do while they're testing the turbine blades. After everyone's done, then we talk about it. Hey, who had the best design? What made that the best design? Et cetera. How does that compare to actual wind turbines? There's a lot of great discussions that we can have going forward. I'll show you a picture of what the setup looks like when I'm done going through this Google form, and it'll be pretty self-explanatory. So that was wind power here. Hey, design a shape for the blades of the wind turbine. What shape did you design? A little bit of addition. Why did you choose this design for the wind turbine blades? And it is cool. I get big wind turbine blades, small ones, skinny ones, curved ones. Just every design, and the kids really think it through, which is really neat. A little bit of review on how the wind turbine make electricity, and you'll be able to see the turbine in my picture, what it looks like. How do you know that the turbine generated electricity? So I had mentioned that we measure the voltage that is produced by the different turbines. It's fun to have a little healthy competition, and we measure it with a multimeter. And those are actually the Create Energy group gave me one from the workshop that I went to. So you get a lot of swag when you do those often. But those are pretty easy to buy. You can post. How much electricity did your blade design generate? And of course, how would you redesign your blades to make them more effective? So, a little bit of takeaway is they observe what they did and the results they got versus other folks. So I had mentioned that many people in the community where I live would think wind power was awesome, and it's not. The next part actually has them going to a web resource. It's a mapping activity where they can look at different locations that have different amounts of wind. And so this is a screenshot of one of those. Then there's a link, and then that link will take them into that mapping activity where they can then answer some questions. So which direction is the wind going? What state has the greatest wind capacity? What does that mean? Why do you think that is, etc. So that's great. In the meantime, I also have them exploring solar power. And I pass around something called a lux meter, which I also got from the Create Energy workshop. And this just has them looking at how angles affect the amount of light that is received, which is a great springboard for talking about seasons, but we use it for discussions about solar panels. Then this is a really neat thing. They can actually type their address into this website called Project Sunroof, and they can see how good of a setup their roof has for solar power. So it makes it really personal. It's basically like Google Earth for your home with solar power. It also evaluates the environmental impact, which is super awesome because then it can see the difference that solar would actually make. I then ask them to go to a totally different location. Like we're in Colorado, so maybe they would choose a place in Minnesota or Maine or Montana or Florida or someplace that's very different. And they would change the factors to see how that changed the impact of the solar panels. This last link currently is not working. I left it in there though as a placeholder. It enables you to change the angle of the solar panels and see the impact it made. And I'm looking for another site that will work, or I'm still troubleshooting this site. I will need to use it again for a few months. But if I can't find something, I'll just take it out of there. But like I said, it's a placeholder for me right now because it's great for them to see some of what they had learned through this. So that's all of that. I'm now to go to pictures. Here's just some quick here. This is an example of lux meters that we use right here in the middle. Here. It is actually during the lesson. So you can see the students, they're working on the Google form, and they're also working on their turbine blades. They're cutting those out. and they're going to actually bring their turbine blades back to the turbine. We just tape them onto the turbine. I have a giant fan in the turbine. So I also workshop. We test it out, and then they bring that information back to their team and or back with their team and continue working on that lesson. Then we get to, we can all talk about it afterwards and talk about what worked, what didn't work, what they learned about wind power and solar power. So basically, this was all born out of an effort of me trying to run the circus, if you will. I didn't want a bunch of kids standing around watching, but I also wanted them to be able to test it out, because I just think this is so cool for them to actually see wind power at work. It is funny with sixth graders, they say, did we make perpetual energy? Because can't you just make the fan run the turbine and make that run the fan? So no, I can't do that. But anyway, it's fun. So there we go. Questions on that one?
Yeah, we've got a couple questions, Greg. First one, so to what extent is energy storage, whether it's on site or kind of at the utility scale, discussed with the students as part of this activity or sort of your larger, kind of learning objectives?
That's great. I would say not heavily. Reason being, it's like I said, it's sixth grade. We do talk about the wind's not always blowing. And so if you're going to lean on wind power as one of your main sources, then you're going to need battery storage and or a diversity of energy sources. So we do touch on it, but we don't get into it extensively.
Okay. And then the second question is, have you had students look at the change in wind speeds relative to elevation and how that might, influence small wind turbines versus kind of large, utility scale wind turbines, either specific to your area in Colorado or just kind of in general for the industry?
Right. No, those would be great additional questions to consider. Like it, also, it just brings up another one. Just the thickness of the atmosphere. I mean, how much of a difference does that make? Curious about that. So yeah, those are great questions. Those would be neat investigations for sure.
Cool. Okay, so those were the questions we have. If there's any others, feel free to type them in the chat. Otherwise, we can wrap the webinar up and obviously relay any questions to Greg through his email. So the next one come in, have you considered having your tech colleague come in to talk about programs they offer in energy management and renewable energy? Really good to get them thinking about those pathways early. So just relaying to your students, sort of the career paths that, might be available if they, find this fascinating topic.
We do talk about that. It's funny. Some of my so I mentioned that the local electricity company comes in, and some of those presenters from the electric company are actually my former students. So we do have a bit of that discussion. I had learned from my workshop that the field is really, really strong right now for alternative energy. So I do talk about that with students, but not extensively. Like I said, they're 11, so their brains aren't completely on that, but it's a great place to introduce that. I did have one student this year. He is excited about being a lineman. He's like, I know what I'm doing, and it's just really neat because getting to meet some of those people from the electric company. But no, 11 years old. I mean, they are thinking mostly about lunch, but it is a great place to introduce it.
Yeah, and obviously being not too far from NREL in Golden is, there's obviously a lot of energy that emanates from that as a resource, a local resource. Another question is relative to the Kid Win kits, that you've been using, how have they held up, from the standpoint of just parts wearing out or components that you maybe needed extras of that would be helpful for us to improve that resource?
I'm good. A great question. Mine good, and I think part of the reason they're still in good shape is I don't let the kids handle them. And I feel bad about that because the more things kids can handle, the better. But as you can see on my screen in the setup, I literally just leave tape attached during the lesson. And when they come back, they hand me their blades and I just tape them on there. Um, so I haven't had any maintenance issues or anything like that with the kits. They're holding up strong. I think I am fairly certain that if I did just have several of these kits and let the kids go to town with them, with my age group, I think they would get damaged pretty fast, but they're doing great.
Great. Any other questions from the audience? Okay, well, we can wrap it up. Thank you so much for presenting today, Greg. We really appreciate your activities and look forward to seeing how those evolve over time and, broadcasting those, to other educators across the country.
That's Gabby here. Greg's going to make his lessons available too for us on the website. So they'll be available for anyone who wants them. So thank you, Greg.
And I would just want to add to all that. Thank you so much for the opportunity. And thank you, everyone, for your great questions. It's fun to be in a room, so to speak, with teachers. And just really great to bounce ideas off of one another. It's a great way to improve all of our teaching. And I would just add, boy, if y'all have any questions about what any of that looks like, please, by all means, let me know, and I'd be happy to share.
Sounds good. Thank you, Greg.
Thanks,
Thanks,
Greg.
Greg. Great to see what you guys are doing down there. It's fantastic.
Thanks, everyone. Have a good weekend.
You too.
All right. All right, we're good.